So, good day everyone. Today I'm going to discuss about the principles of geology. So, our subtopic will be Mineralogy and Petrology 1. So, let's start. So, mineral and petrology. What is mineralogy? This is the systematic study of the chemical compounds or uncombined elements found in rocks. So, yung mineralogy is yung pag-aaral, step by step na pag-aaral ng chemical compounds or uncombined elements na makikita sa mga bato. So what is petrology? This is the systematic study of the nature, processes, and uses of rocks. So sa petrology naman, ito naman yung step by step din na pag-aaral, pero about sa pinanggalingan or saan sila gagamitin and yung mga pinagdadaanan ng bato. So we have here minerals. These are building blocks of rocks. A substance can be classified as a mineral as long as it achieves all of the following conditions given by the acronym NIDO, or naturally occurring, inorganic, homogeneous solid, definite chemical composition, and ordered internal structure. So what is naturally occurring? So ito yung sa nature nangyayari. So ibig sabihin, walang man-made na or walang human intervention sa paggawa ng mineral na to. So, inorganic. So, ibig sabihin, non-organic elements or non-organic materials yung bumuo sa minerals na to. Homogeneous solid. So, ibig sabihin, walang halo-halo. Isa lang. Isa lang yung isang composition lang meron sila. And definite chemical composition, yun na nga, isang composition lang. Tapos, yung isang chemical composition, and yung chemical composition na yun, dapat talaga. Parang sabihin natin na yan talaga yung chemical composition niya. Walang nagtatago or walang ganun. So, ordered internal structure. So, ordered internal structure, ibig sabihin, is meron siyang internal structure na may pattern. Hindi siya yung kalat lang yung internal structure niya. So, yan yung ibig sabihin ng nido. So, crystals. These are solids in which the atoms are arranged in orderly repeating patterns. They have geometric forms featured by smooth surfaces. Crystals form by many processes. The two main methods are as follows. Number 1. Formation from magma. As magma cools, each atom loses heat energy, move closer together, and begin to form compounds. During this process, atoms of the different compounds arrange themselves into an orderly repeating pattern. The type and amount of elements present in a magma partly determine which mineral will form. Also, the size of the crystals that form depends partly on how rapidly the magma cools. So, dito sa number 1, formation from magma. So, ibig sabihin, galing to sa mga bulkan. So, ito yung crystals na galing sa bulkan. Either nilabas ng bulkan via eruption or dahil sa pressure, dun na mismo sila nabuo sa gilid or dun sa lining ng magma. So, we have formation from solutions. Crystals also can form from minerals dissolved in water. When water evaporates, as in a dry climate, ions that are left behind can come together to form crystals. Or, if too much of a substance is dissolved in water, ions can come together and crystals of that substance can begin to form in the solution. Minerals can form from solution in this way without the need for evaporation. So, ito naman sa number 2, ibig sabihin dito is formation from solutions, di ba? So, itong solutions na to is water-based. So, ibig sabihin, may tubig. So, yung unang is dissolved in water. So, kailangan ng evaporation yung unang type. Pag nag-evaporate yung tubig, yung matitira sa baba, yun yung pwede silang magsama-sama, then makakabuo sila ng kristal. Then the other one naman is, pag sobrang marami yung substance na yan sa tubig, na hindi na sila kayang i-dissolve ng tubig. So, pag ganun naman, pwedeng mabuo na lang sila, makabuo sila ng crystal without the help of evaporation. So, ibig sabihin, may tubig sila, may tubig yung may tubig dun sa solution na yon, pero nakakabuo pa rin ng crystal. So, transparency or diaphanity. This is the extent of light that can pass through the mineral. The degree of transparency depends on how thick or thin a mineral is. So, what is transparency? This is the extent of light. Pero may word siya na transparency. Ibig sabihin, may connection sa transparent. So, yung transparent is you can see through. Based dito sa picture. Pero yung transparency, ibig sabihin, siya yung how well light passes through a mineral. So, ibig sabihin, siya yung degree. Yung transparency. Siya yung parang pagbabasehan. Ano yung transparency na mineral na to? Is it transparent, translucent, or opaque? Ganun. So, ano yung transparent, translucent, and opaque? So, we have here sa picture, transparent, you can see through. Makikita mo. Yung example, hinawakan mo yung mineral. Nung tiningnan mo yung mineral, nakikita mo yung kamay mo. Clearly. Yan yung transparent. So, next is the translucent. You can see light but not objects. So, paano ganito? Paano naman yung ganito? You can see light but not objects. So, pag hinawakan mo siya, nakikita mo yung part na madilim kung saan yung hinawakan mo. Then, yung part na maliwanag kung saan hindi natatakpan ng kamay mo. So, ganun yung translucent. So, opaque. What is opaque? Can't see anything. So, pag hinawakan mo, wala kang makikita. Pag gilid lang hinawakan mo, wala ka pa rin makikita. As in, nabablock niya lahat ng color. O ng light. So, we have here translucency. This is the characteristic of a mineral in which the mineral partially lets light pass through. Yun yung kanina. So, main causes of translucency are flaws and inclusions. So, yan yung main cause, di ba? Main cause ng translucency yan. So, we have next is opaqueness. This is a characteristic of a mineral in which the mineral does not let light pass through. Wala talaga. Walang light na makakalusot sa mineral na yan. Yan yung opaqueness. Magnetism. This is the ability to attract and repel other minerals. So, magnetism came from the word magnet. So, ano yung ginagawa ng magnet? Attract and repel. Repel pag same polarity, and attract pag hindi naman pareho. So, ganun sa magnetism. So, ibig sabihin, pag yung magnetic na mineral na yan is, sabihin natin, may nerd polarity. Then, yung metallic items na yan, metallic things na pwede niyang ma-attract, example, iron, pag south yung, hindi, kasi pag iron, dikit talaga. Kahit anong gawin mo, dikit talaga yan. Pero pag dalawang magnetic mineral, tapos, example, pareho nerd pole nila yung pinagdikit mo, either ikot yung isa para maging south, or hindi mo talaga sila mapapagdikit. Ganun yung magnetism. Pero lahat ng magnetic na metal, didikit sa kanila. So, next we have hardness. This is the measure of the mineral's resistance to scratching. Ito naman yung resistance to scratch. Ibig sabihin, hindi mo magagasgasan to. So, we have itong kilala na Mohs hardness scale. Kilala to dahil siya yung considered as the table for the hardness of the mineral. ito yung mga kilalang minerals. Nilagay dito yung kilalang minerals na mula sa sabihin natin nga, pinaka-list yung resistance to scratch up to the hardest one to scratch. So, number 1, we have talc. Talc o talc. So, we have number 2, gypsum. These two minerals are scratchable by fingernail. So, next we have the calcite. From calcite up to talc, they are scratchable by copper coin. So, next we have the fluorite, and number 5 is apatite. From apatite to number 1, which is the talc, they are scratchable by knife and glass. So, number 6, we have the feldspar. So, from feldspar to talc, they are scratchable by steel. So, next we have the quartz. Number 8, we have the topaz. Number 9, the corundum. And number 10, the most, sabihin natin, kilala, o pinakakilalang matigas na mineral, which is the diamond. So, number 10 yung diamond. So, next, axis. So, naputol. Its axis yan. So, luster. This is the quality and intensity of reflected light shown by the mineral. So, ibig sabihin naman na luster is yung quality and intensity ng reflected light. So, ibig sabihin yung binounce back nilang ilaw. So, dito sa picture, we have the example of luster. So, luster, the way a mineral reflects light. So, we have the metallic luster. For the metallic luster, we have galena, pyrite, and graphite. So, we have the non-metallic or dull luster. We have olivine, potassium feldspar, and dolomite. So, anti-stress, si dolomite. So, next we have tenacity. This is the level of resistance or reaction of a mineral to stress. The stress exerted such as bending, breaking, crushing, or tearing. So, sa tenacity, ibig sabihin sa tenacity is level of resistance or reaction to stress exerted. Yung hardness is scratching. So, dito is stress exerted naman. So, breaking, bending, crushing, or tearing. So, next we have the cleavage, fracture, and parting. These terms are used to describe how materials break into pieces. So, sa cleavage, fracture, and parting, how minerals break. Okay? How minerals break. Sa tenacity is the resistance to break. So, halata naman yung pinagkaiba nila, di ba? So, we have your example of cleavage, fracture, and parting. So, we have here the quartz crystal and the rose quartz. Sila yung sila yung without cleavage na minerals. So, next we have our cleavage in one direction. Example, muscovite. And our next, which is the cleavage in two directions. Example, feldspar. So, cleavage in three directions. Example, halite. So, cleavage in three directions. Example, calcite. So, ano yung pinagkaiba nung unang three directions sa kalawang three directions? So, sa una, we have here the cubes. So, ibig sabihin, cubes, either rectangular or square yung faces. So, dito naman sa pangalawang three directions, we have here the hedrons, polyhedrons. Tama ba? I don't know kung tama yung basta mga rhombus or parallelogram yung faces niya. So, next we have odor. This is the distinct smell released from a chemical reaction when subjected to heat, air or friction. So, ibig sabihin naman, pag ito yung nilalabas na amoy ng mineral, pag naiinitan, na-expose sila sa hangin kasi, so, bakit asali yung hangin? Kasi pag yung ibang mineral is, sabihin natin na, under pressure sa ilalim ng lupa. So, pag hinukay mo yan, may expose sila sa hangin. So, may chance na mag-release sila ng amoy. So, yun yung dahilan bakit kasali dito yung air. Friction naman is mostly related to heat kasi continuous friction between two things will create heat. So, kaso, ang problema lang, dito sa heat na sinasabi dito is direct, yung mula talaga sa apoy. So, isa yung pag ininit, pag na-expose sa hangin, or pag nagkiskisan yung dalawang mineral. Or taste. This is the distinct taste of a mineral. Yes. May minerals na pwedeng, sabihin natin na pwede naman kainin. Ganun. Example is yung table salt. Hindi yung iodized, yung table salt, yung talaga, yung kinuha mismo sa dagat directly. Tapos pinatuyo lang, then hinati-hati as ito. Hindi naman hinati-hati. Sabihin natin na crushed, yun. So, medyo maalat siya automatic kasi salt niya. So, ganun. Yung ibang minerals is may lasa talaga. Next is we have specific gravity. This is the measure of the density of a mineral. Its value is calculated from the ratio of the mineral's weight to the weight of an equal volume of water. It is usually used when two minerals have the same color and size. So, yung specific gravity is almost the same as density. Kasi, density talaga ang mini-measure. Density sa tubig. So, ibig sabihin, meron tayong 1 cm cube na cubic volume of water. So, ibig sabihin, 1 cubic yan na volume ng water. So, measure yung weight niyan. Tapos, meron tayong 1 cm cube or 1 cubic centimeter na volume na mineral. The same lang, di ba? Kukunin din yung weight niyan. So, yung ratio between those two weights, yan yung density ng mineral. So, saan ginagamit yung specific gravity na ito? Diba kanina sa color, we have minerals that have the same color and size. So, paano natin malalaman yung anong klaseng mineral to nang hindi sila pinapakailaman? So, measure specific gravity. Check mo kung ano specific gravity nila. After mo ma-check, tingnan mo sa table kung may listahan ka or search mo sa internet kung anong klaseng mineral yung may ganitong specific gravity. Then yun, malalaman mo na kung ano mineral yan. The fluorescence. This is the ability of a mineral to light up when exposed to ultraviolet light, X-rays, or cathode rays. So ito naman is, pag nailawan to ng ultraviolet light, X-rays, or cathode rays, umiilaw sila. So, mostly sa kuweba to. Since, for some reasons, yung sabihin natin na cave explorers, bukod sa ilaw, sa normal light, or normal flashlight, nagdadala din sila ng ng mga UV light. Hindi ako sure about sa purpose nun. So, siguro, especially kasi pag may kasama silang archaeologist or mga ganyan, basta inclined sa sa mga naghahanap ng mga evidences from the past. So may nagdadala sila ng ultraviolet light. Diba, pag nakita na itong place, ilawan nila ang ultraviolet light kasi yung ibang evidences is umiilaw pag na-expose dun. So, pag nakita nila, i-check nila kung ano yun. Then, if may connection sa past, iyan nila as evidence. I-check nila kung saan part pwede maging evidence. So, next, this is the phosphorescence. This is the ability of a mineral to briefly emit light even after cutting off the light source. So, dito naman, after mo dito sa picture, long wave UV light source removed. So, bakit umiilaw pa rin? So, di ba kanina, in-explain ko yung UV light. Pag may dinaanan sila, tapos di nila napansin na umiilaw pala yun, saktong tinanggal niya yung UV light, may chance na umiilaw pa yung mineral na yun. Pero hindi na ganun ka liwanag. So, tawag dun is phosphorescence. We have chiatancy, also known as the cat's eye effect. Chiatancy is an optical phenomenon wherein a mineral tends to have a certain optical reflectance effect. So, optical reflectance. So, ito yung pattern or design ng liwanag na nire-reflect nila or design ng light na nire-reflect nila. So, bakit cat's eye effect? We all know na pag nailawan yung mata ng pusa, nakakatakot. Bakit? Umiilaw din yung mata ng pusa, may hati pa sa gitna. Ganon yung chiatancy effect. Chiatancy na property ng mineral. Pag nailawan sila, nagre-reflect sila ng ilaw and may light na humahati sa mineral na yun. So, next we have asterism. This is a type of chiatancy in which the viewer sees the intersection of multiple cat's eyes or a star rather than a single cat's eye. This results in a star-shaped figure exhibited during light reflection or transmission. So, dito naman sa asterism is maraming mata ng pusa. Medyo. Iisa lang. Pero yung design niya is parang star. 6-sided, pwedeng 8-sided, pwedeng 4, depende lang din. Pero mostly 6 yan. Para makabuta na ganun So, consider siya as star na, yung design. So, that's asterism. We have the idiochromatism. This is the ability to have distinct color even when pure. So, what is idiochromatism? Distinct color even when pure. Ibig sabihin, kahit wala silang impurities, may color pa rin sila. Kasi yung ibang minerals, pag tinanggalan mo ng impurities, nagiging clear. Yes, nagiging either white or nagiging clear. So next we have allochromatism. This is the ability to have a color that is due to the presence of impurities. So ito naman yung type ng mineral o properties ng minerals na nagkakakulay sila dahil sa impurities na meron sila. So thankful sila sa impurities dahil kung hindi dahil sa impurities na yun, wala silang kulay ngayon. So dito sa picture, we have the idiochromatic if the color is always the same, and allochromatic if the color varies due to impurities. So next, color. So next, we have double refraction. This is an optical phenomenon exhibited on certain minerals where a light ray enters the crystal and splits up into two separate rays. It is measured with a refractometer. So, double refraction. Ito yung phenomenon na pag inilawan mo yung mineral na yan, yung ray na lalabas sa kanya is hindi isa, dalawa. So, mostly sa prism nangyayari ito. But sa prism, pag chinek mo yung prism, ilawan mo, may isang, di ba, sabi nga UGB may lalabas na color. Mayroon isang ray dyan na clear lang. Kasi normal lang siyang ilaw. Halos hindi siya mapansin. Pero, ray din siya. Ganon yung double refraction. May refraction dito, may refraction dito. Pero, isa lang yung source. So, next we have dispersion. This is the splitting up of white light into its individual wavelengths, what we see as colors. Dispersion occurs when transparent surfaces that are not parallel to each other. So, ito naman. Bakit nagkakaroon ng dispersion? So, dispersion occurs with transparent surfaces. Kasi nga, that are not parallel to each other. So, parang mirrors to na magkadikit-dikit. So, pag inilawan mo, kasi nga, di ba, ano to, transparent, ibig sabihin, multiple prisms to, yung mineral na to, pero hindi parallel, ibig sabihin, angles nila is iba-iba, yung prism na yan. So, ano mangyayari? Magkakaroon ng hindi naman bending, sabihin natin rebound of light. So, ibig sabihin, white light yung unang papasok, then lalabas is yung rainbow, yung RGB. Then yung RGB na yun, babangga na naman. Doon sa ibang babangga ulit. So, yung mangyayari is, habang tinitingnan mo yan, mapapansin mo na iba-iba yung color na lumalabas. Or hindi lumalabas, na nakikita mo sa mineral na yan. So, ganun yung dispersion. So, next we have polymorphism. This is the ability of a specific chemical substance to crystallize in more than one configuration, in which is dependent upon changes in temperature, pressure, or both. So, dito sa picture, we have polymorphism. We have 3 mm of natural octahedral diamond, which has crystallization of octahedral. So, natural lang siya, okay lang. Pero mapapansin nyo na may triangular siya sa faces niya. Ibig sabihin, hindi smooth. Or, meron pa siyang ibang crystallization bukod sa octahedral. So, next we have graphite and calcite. Ito naman is naghalo. So, either sinakop ni calcite yung graphite, kaya naging ganyan. Which causes to abnormal crystallization. Parang ito, imbis na mag-crystallize yung graphite based dun sa crystallization or sa crystal habit niya or sa tsura niya, naging iba dahil nga nahaluan siya ng calcite. So next, they have the feel or texture. This is the feel or shape of a mineral. So sa feel or texture, this is the feel or shape of a mineral. So ito yung nafe-feel mo pag hinahawakan mo yung mineral. So napansin mo yung iba is makinis, yung iba is parang lubak-lubak na kalsada ganun. So next, we have solubility. This is the ability of minerals to be dissolved in a certain amount of solvent at a specific condition. Ibig sabihin, dissolve in certain amount of solvent. Madidissolve yung mineral na yan in a specific condition, either kumukulo or napakalamig na tubig. Or depende sa solute mo. Solute ba tawag yun? Or solvent. Basta madidissolve yung mineral pag hinalo. So, next. So, mostly So, next ulit. So, in presence of striations. Striations are perfectly straight parallel lines or sketches on mineral surfaces, usually no more than a few millimeters in depth, produced by the process of glacial abrasion. So, ito yung nakikita natin sa minerals na straight lines. Actually, hindi naman siya as in straight talaga. Pero pero parallel lines. So, ibig sabihin, no intersections. And hindi siya gaano kalalim. So, mostly makikita natin ito sa malapit sa lugar kung saan may glaciers or may mga ice. Since this is caused by glacial abrasion. So, next is the feasibility. This is a measure of how much heat it takes to melt a mineral into a globule, or at least to melt the sharp edge of a sharp splinter and make it round over. So, ito naman yung ito yung pag-measure how much heat it takes to melt a mineral into a globule. Hindi ito yung melt a mineral na yung tunaw talaga. Ito yung melt ng mineral or melt ng edges ng mineral until they can be formed into a into a globule or parang sphere, ganun. Pero hindi siya yung perfect sphere. So, pwedeng sabihin natin na walang sharp edges na, ganun. So, yun yung fusibility. We have piezoelectricity. It is the ability to generate a voltage in response to applied mechanical stress. So, ibig sabihin, pag piezoelectric properties, temperature, pressure changes cause some minerals to acquire an electric charge when warmed, cooled, or pressed. So, ito yung nagkakaroon sila ng voltage in response to applied mechanical stress. So, ito yung pwede silang gawing conductor. Pero, bago sila maging bago sila pwede maging conductor, they need to be applied or kailangan silang lagyan ng mechanical stress. Or kailangan nila experience muna is mechanical stress bago sila makapag-generate ng voltage. So next we have pyroelectricity. It is the ability of a mineral to generate voltage as a response to temperature variations. At ito naman is change in temperature. So, ibig sabihin, pero mostly dito is pag mas mainit. Pag mainit na masyado, nag-generate sila ng electricity. Yung mineral na yan. So, yun yung pyroelectricity. So, next, we have the effervescence. This is the escape of gas from carbonates. So, effervescence, this is also where the word effervesce or fizz means kumukulo. Pero hindi yung kulong sabihin natin na bagong bukas yung soft drink, then di ba, pag nilagay yun sa baso, medyo nagbubula. So, tawag dyan, di ba, fizz. Ganun yung nangyayari sa effervescence. Pag nilagyan mo ng ng hydrochloric acid, especially the carbonate materials or carbonate minerals, they fizz. Nag-effervesce sila. Kasi nga, unstable. So next we have radioactivity. This is an attribute of minerals that contain radioactive elements. Example of radioactive elements is uranium. So radioactive minerals are unstable, katulad sa carbonate minerals. Pero yung carbonate minerals is unstable lang pag may hydrochloric acid. Pero dito sa radioactive minerals, they are unstable because of their elements. So, meaning the elements in their structure continually break down. So, paulit-ulit na nag-breakdown yung elements sa kanila. This destroys the mineral's crystal lattice, causing it to lose its crystal shape. So, ibig sabihin, wala silang crystal shape or crystal habit. Yung shape nila nagde-depend sa breaking down ng elements nila. So, next, we have twinning. It occurs where one part of a crystal has been deformed such that its atomic structure is rotated or reversed compared with the other part. The result is an intergrowth of two separate crystals in a variety of specific configurations. So, ibig sabihin dito is, in twinning, parang ganun. Parang twin. So, kambal. Either reversed or rotated. So, dito sa example sa picture, that is reversed. Kasi nga, or parang mirrored, actually. Kasi, di ba, punta siya sa left. Then yung bagong tubo is punta naman sa right. Pero the same lang yung crystal habit nila. We have electrical conductivity. This is the ability of a mineral to conduct electricity. And next, we have the thermal conductivity. This is the ability of a mineral to conduct heat. Dito malalaman kung conductor yun ng electricity or ng heat yung mineral. So next, we have the pseudomorphism. This is the existence of a mineral that has the appearance of another mineral. Pseudomorph means false form. So, dito sa pseudomorphism, ibig sabihin nito is ginagaya ng isang mineral yung itsura ng isang mineral. Nakakalito. Pero example dito is opal after globerite. So, ginaya ng opal yung globerite. And yung quartz naman, quartz after halite is ginaya ng quartz yung halite. Then, jasper after wood, ginaya ng jasper yung itsura ng wood. So, ganun yung pseudomorphism. So, next we have phantoms. This is the ability to continue growing even when the crystals stop growing. So, ibig sabihin, kahit na huminto yung crystal sa pag-grow, may part ng crystal either sa loob ay sa labas na may part yung crystal na tumutubo pa rin kahit yung main crystal hindi na tumutubo. So, ganun yung phantoms. So, inclusions. These are materials that are trapped inside another mineral while that mineral forms. For example, other than minerals, water, tar, and petroleum, and even animals. So, ibig sabihin, ito yung inclusions, yung nasa loob ng minerals habang nagpo-form sila. So, dito sa picture number 2, that is petroleum, yung nasa loob niyan. Kaya ganyan yung color. So, the identification of minerals. So, first we have microscopic analysis. This is the method of identification of minerals that uses primary naked features such as color, luster, and crystal shapes of a mineral to identify its nature. Also, the use of a hand lens, which has the magnification of ×8 or ×10 in observing the diagnostic features is prominent. So, ibig sabihin, megascopic. Ibig sabihin, malaki. Megascopic. So, scopic is zoom. So, ibig sabihin, malaki ang zoom. So, use of hand lens which has ×8 magnification or ×10 is already considered as megascopic analysis. So, yung check nyo lang dito is color, luster, and crystal shapes of a mineral para ma-identify yung nature niya. So, next, we have testing methods. We have the petrographic analysis. The petrographic analysis, this is the examination of a thin slice of a mineral where the sample is ground down to a thickness of 0.03 mm and is observed with the help of a microscope. So, dito sa petrographic analysis is hindi na hand lens yung gamit niya. Gamit niya is microscope kasi nga gina-ground yung or kina-crush yung mineral into thickness of 0.03 mm. Napakaliit niyan. So, napakaliit ng thickness. Napakanipis na yan. So, hardness test. This is the test for the abrasive property of a mineral. The instrument used to measure absolute hardness is called sclerometer. So, para tong ball pen, yung sclerometer na to. So, hardness test, ito yung, dito binase yung most hardness test. So, chine-check nyo dito kung gaano katigas yung mineral na yan. So, we have the acid test. This is a simple chemical test to identify the presence of calcite, which makes up most of limestone and marble deposits. Calcite is a compound calcium carbonate. If a drop of cold muriatic acid is placed on a calcite, bubbles of carbon dioxide escape. That is the mineral effervescence. Calcite is one of the few common minerals that react in this way. dolomite. A carbonate of calcium and magnesium gives the same reaction with hot acid but reacts slowly with cold acid. So, ibig sabihin, dito sa acid test is ginagamitan yung mineral na, at pinapatuluan yung mineral ng acid. So, mostly hydrochloric acid yung ginagamit dito. So, sa after matuluan, chine-check nila if nag-effervesce yung mineral. Pag nag-effervesce yung mineral, that means may calcite na laman yan. So, what is calcite? Compound siya ng calcium carbonate. So, ibig sabihin, di ba kanina sa effervescence, pag carbonate mineral, nag-effervesce pag tinuruan na pag tinuluan ng calcium, ng hydrochloric acid. So, ibig sabihin, ganun din mangyayari dito sa acid test na to. So, mostly, check to para sa presence talaga ng calcite. So, next we have the blowpipe test. This is executed with a short bent tube with a tiny outlet, through which air may be blown into a flame to produce a smaller, hotter flame. According to how the blowpipe is used, oxygen enters into reaction with the mineral, or hot gases are produced which take oxygen from the mineral. These flames are described respectively as oxidizing or reducing flames. So, oxidizing and reducing flames. Oxidation. Ang problema lang is apoy. Yung ina-oxidize. Kasi nga, chine-check dito is yung oxygen. Kasi nga, di ba, pag may oxygen, ibig sabihin, patuloy lang yung apoy. So, tinatanggalan nila ng oxygen. Yung mineral na yun. Or pwedeng nilalagyan nila naman ng oxygen, yung mineral na yun. So, next, flame test. This is a test wherein a bit of the powdered mineral is moistened with acid and held on a clean platinum wire. This will then put into the flame. The resulting change in color of the flame indicates the presence of certain elements. So, dito sa flame test, kinukuha mo na yung straight ng mineral. Then after kunin yung straight ng mineral, yung powdered form na yun is hinahaluan ng acid. After haluan ng acid is ilalagay yung moistened powdered mineral sa clean na platinum wire. Bakit platinum wire? Kasi platinum wires are the wires that doesn't affect the color of the flame when hot. So, ibig sabihin, kung anong kulay ng apoy na yan, pag nilagay mo yung platinum wire, hindi yan magbabago. So, best gamitin para sa flame test. So, example dito sa flame test na to is, chine-check pag may sulfur. So, sulfur can create, if I'm not mistaken, orange or yellowish na flame. Meron ding elements na nagke-create ng blue. Meron din nagke-create ng green. The shades will differ depende na lang sa elements na nandun. So, next, bead test. This is a test wherein a clear bead of borax is formed on a loop of platinum wire. The loop is dipped into powdered borax and then held in the burner flame. The borax bead is then touched to the powdered mineral. When placed in oxidizing or reducing flames, the borax and minerals react to produce a characteristic color determined by the elements of the mineral. So, parang flame test din to. Problema lang is gagamitan mo ng borax. Then, mas complicated yung process dito. Pero the same lang yung check. So, next, X-ray analysis. This makes use of the definite structure found in every mineral. When a beam of X-ray falls on a crystal, the diffracted X-rays are allowed to fall in a photographic plate, and the resulting photograph shows a series of spots or lines in which form a more or less symmetrical pattern. This X-ray analysis of minerals reveals their actual atomic structure, which is distinctive for each mineral. So, X-ray analysis. So, chinecheck dito is yung epekto ng X-ray sa crystal. So, ibig sabihin, iilawan ng X-ray light o X-ray yung crystal na yan. Then, yung crystal mabibigay ng diffracted beams, which will be gathered by the photographic plate. Then, i-check nyo din diffraction pattern. So, makikita dun yung atomic structure ng mineral na yun. So, every mineral has distinctive atomic structures. Ibig sabihin, iba-iba sila, bawat mineral. So, pag ginawa tong X-ray analysis na to, kahit wala na yung ibang test, malalaman mo agad kung anong uri ng mineral yan. We have the scanning electron microscope or SEM and energy dispersive spectrometer or EDS. The SEM uses an electron beam to yield a high-resolution image of the mineral surface and shape. Most SEMs are equipped with EDS that significantly measure characteristic energies of elements to determine their composition. So parang hand lens lang to, pero mas high resolution and mas clear yung makikita mo. Then, pag may EDS, makikita mo din yung characteristic energies ng elements na natutulong para ma-determine yung composition ng mineral na yan. So next, we have chemical composition diagram. This graphical representation is used to show the molecular percentage of elements that combine to form the multiple minerals within a particular mineral group system. The format of the diagram consists of a triangle with the native element shown at the apex and lower corners. Percentile marks are shown along the sides of the triangle and series of dots and lines section of specific areas that reflect the percentage of a native element present for each member of the group. The percentages present are read at the intersection points on the line. Nabulol ako dun. So, ito yung chemical composition diagram. So, chine-check niya is yung yung chemical compositions ng bawat minerals. So, pressure time diagram. This is a graphical representation that is often used to display the stability of a particular mineral group or minerals. This diagram uses basic graph format with pressure shown on the y-axis and temperature shown on the x-axis. So, ibig sabihin, pataas ng pataas yung pressure sa y-axis. Sa x-axis naman is yung temperature. So, we have here at the highest temperature and highest pressure, we have the eclogite. So, meron din dito naman sa medyo mataas na pressure pero napakataas na temperature, we have the granulite. So, yan yung example. Meron ding lower pressure pero mataas yung temperature. We have the sanidinite. Yan yung examples. Uses of minerals. So, uses of minerals. First, we have uses of minerals in jewelry. We have A, pyro, B, jade, native gold, topaz, and auriferous quartz. So, these are minerals that are famous for being used in jewelries. The second one, we have minerals that are used in cosmetics. Ito yung minerals na ginagamit sa makeups, sa lipsticks, ganun, or anything na related sa cosmetics. So, we have our first, which is the talcum powder. This is used for baby powders, eyeshadows, and blushers. So, talcum powder siya yung madalas makikita natin sa mga pambata and mga and mga powdered na cosmetics. So, titanium dioxide, this is used for whitening creams, sunscreens, and lubricating cream. Mica, this is used for skincare products with a glow effect. Zinc oxide, this is used for acne remover and lubricating cream. E. Iron oxides, these are used for lip-based products and blushers. Calcite, this is used for microscopes. Or this uses of minerals for medicine. So first we have calcite. This is used for microscopes. Cinnabar. This is used for thermometers. Sa thermometers, both sa mineral cinnabar, common din yung element na mercury. So, pero since meron na tayong electric thermometers or yung digital thermometers, mas mas safe siya kontra dun sa traditional thermometers na may mercury. Lalo na pag dispose pag sa kailangan na i-dispose. So next we have pyrite, which is used for sulfa drugs. Halite, this is used for electrolytes. Dolomite, this is used for constipation and eclampsia. So pag masakit yung tiyan mo, may chance na yung may constipation ka, may chance na yung gamot na iniinom for constipation yung gamot na iniinom for constipation is may dolomite. So next we have for agriculture, uses of minerals for agriculture. We have apatite, this is used for fertilizers. Sylvite, this is used for fertilizers too, and also gypsum. So for zeolite, this is used to control the moisture content of soils and increase the pH of acidic volcanic soils. Not familiar with this mineral. So next we have galena. This is used for insecticides. Use of minerals for energy. So we have graphite. This is used for nuclear reactors. Graphite is also used in creating pencils. Sila yung sinasabi ng iba na lead sa lapis. Pero actually, hindi yung lead. That was graphite. So next, we have halite. This is used as a heat exchanger in nuclear reactors. Uraninite, this is used for nuclear reactors. Opal, this is used for petroleum products. Azurite, this is used for solar, hydrothermal, and wind energies. So, mapapansin nyo sa energy, mostly, sa nuclear reactors, ginagamit yung minerals. So next, we have use of minerals under construction. So, first we have quartz. This is used for silica, bricks, and concrete. Pwede din siyang gawing furnitures, katulad nung nakita ko sa social media recently na yung ginawang dining set yung rose quartz, which was beautiful, although para siyang karne tingnan. Lalo na yung pagka hati or yung pagka design ng dining set na gawa sa rose quartz. Pag nakita mo siya first time, isipin mo na malalaking karne. So next we have chlorite. This used for steel making. Pinahalo siya sa mistaken iron. To create steel. Then calcite. This is used for Portland cement and limes. So calcite the same as ito yung bad Portland cement. Portland cement is famous for being fast dry cement. So ibig sabihin mabilis siyang matuyo. And with the same quality as the other cement. Mas mabilis lang siyang matuyo, so mas bagay siya sa indoor part ng house, since hindi na ng araw yung indoor part ng house. So mas less yung chance na magkaroon ng water deposit yung pader nyo. Pader ba tawag? Basta yung wall. So, ilmenite. This is used for structural metals. And last, we have beryl, which is used for production of lightweight alloys. So, last, uses of minerals, which under household. So, we have kernite. This is used for soaps, enamels, and glasses. Feldspar, this is used for ceramics and glasswares. Fluorite, this is used for toothpaste and glasses. Pulp, this is used for paints and ceramics. Kyrolite, this is used for porcelain, glass, and bowls. Meron din isang mineral na ginagamit siya as roof. Yes, roof. Ginagamit siya as roof. Or, I don't know kung siya mismo yung ginagamit as roof or hinahalo muna siya. Basta meron siyang isa lang yung cleavage niya, isa lang. So, ibig sabihin, thin sheets yung niya, yung pagkahati-hati. Then pinagpapatong-patong yun para makagawa ng bubong. So, you have rocks. These are solid masses found on the lithosphere and are naturally occurring solid mixtures of one or more different minerals and other organic matter. Such assemblages constitute the basic unit of which the solid earth is composed and typically form recognizable and mappable volumes. So, I guess we're not unfamiliar with rocks. Kahit saan ka tumingin may bato, except lang sa langit. So, we have classifications of rocks. So, first classification of rocks is igneous rocks, from Latin word meaning fire. So, may hint na kung saan galing igneous rock kasi fire. So, these are rocks that are formed from solidification of magma. Magma is molten rock that is most often generated by the melting of rocks in Earth's mantle. Crustal rocks also generate some magma. So, yung galing sa yung bato na galing sa magma or kakalabas lang from eruption of volcanoes and other types of na pwedeng daanan ng magma to the Earth's surface. Basta yung rocks na galing sa magma or galing sa lava if it came from an volcano eruption, pag lumamig yun, yung kalalabasan is igneous rocks. So next we have sedimentary rocks, from a Latin word meaning to settle. So these are rocks that are formed from the accumulation, compaction, and cementation of sediments at the surface or near the surface. So, may types tayo ng actually hindi siya types, parang siya ng sedimentary rocks. So, you have these natural and actually, parang natural din siya. Yung lang kasi is, yung sediments, yung pinanggalingan ng sediments, kung saan galing yung sediments na yun. So, we have metamorphic rocks, from a Latin word meaning to change. These are rocks that are formed from the transformation of pre-existing rocks through heat, pressure, or chemically active fluids. So, metamorphic rocks, these are rocks that are formed by weathering or anything na anything na magkakos ng transformation or pagbabago doon sa pre-existing rocks. Example is, etong batong to is na-expose sa halimbawa, etong bato nakuha mo siya sa hot place. So medyo mainit siya, di ba? Or sanay siya sa init. Then nilagay mo siya doon sa lugar na malapit sa poles. So ibig sabihin medyo malamig na. So ibig sabihin magbabago yung para magkakaroon ng maninibago yung bato. So, ibig sabihin, magkakaroon ng transformation yung batong yun para sabihin natin, adapt or para bagay siya dun sa place na yun. Or pwede rin chemically active, which is means ginamitan mo ng chemical yung batong yun para mag-iba. So, we have rock cycle. Rock cycle is the model that describes all processes by which rocks are formed, modified, transported, decomposed, melted, and reformed. Ito yung parang sabihin natin pudging. Pero dito is yung cycle naman. Kung ano lahat ng pinagdaanan ng bato. Ayan. So, the rock cycle links the principal rocks together in idealized view of the sequential evolution of rocks in the crust. So, ibig sabihin, ito yung nag-link sa mga bato. Sabi, bakit itong batong to after ng ilang years naging ganito? And after ng ilang years, bumalik sa ganito or naging ganito. Ganun. O bakit itong bato nag-skip ng ganito, nag-skip dito din para mapunta agad dito. Parang ganun. So, we have these pathways sa rock cycle. So, these are igneous to sedimentary. The lava crystallizes and produces extrusive or volcanic igneous rocks. Consequently, the rocks undergo weathering and erosion, generating sediments. The sediments undergo diagenesis, which solidifies into sedimentary rocks. So, from igneous to sedimentary. Yes, galing igneous sa rock. Galing yung bato galing sa igneous. Example. Then, haluan siya ng sediments during weathering and erosion. Sabi sabihin, parang napupunta sa kanya, dumidikit sa kanya yung sediments. Then, after nun, nag-undergo siya ng diagenesis, which solidifies into sedimentary rocks. Ibig sabihin, yung igneous, after yung diagenesis, nagiging sedimentary rock siya. Okay? So, next they have sedimentary to metamorphic. The sedimentary rocks are buried or involved in orogenesis, subjecting them to great pressure and heat. It turns into a metamorphic rock once it's significantly different from the parent rock. So, ibig sabihin, yung sedimentary rocks, na subject siya sa great pressure and heat. Maybe man-made or natural, lalo na sa heat and pressure. Sabihin natin, araw-araw dinadaanan yung batong yun ng malalaking truck, which creates great pressure dun sa bato. Then, saktong laging napakainit sa lugar na yun. Then, talaga magbabago talaga yung batong yun. So, it turns into a metamorphic rock once it is significantly different from the parent rock. Significantly different. Ibig sabihin, ang laki na ng pagkakaiba ng batong yan kung i-compare mo dun sa kung ano siya dati. So, ibig sabihin, metamorphic na siya pag malaki na yung pagbabago. Once na hindi pa malaki masyadong pagbabago, consider it as sedimentary pa rin. Okay? Next, metamorphic to igneous. If the metamorphic rocks continue to be subjected to heat and pressure and melt into magma, they become igneous and the cycle begins again. So, ito naman, pressure and heat sa Earth's crust, lalo na malapit sa magma. So, ang mangyayari dito is they become igneous and the cycle begins again. So, ulit lang yung cycle na yun. So, we have alternative paths. Rocks do not necessarily go through the cycle in the order just described. The other paths are also possible. For example, rather than being exposed to weathering and erosion at Earth's surfaces, Igneous rocks may remain deeply buried and be subjected to strong compressional forces and high temperatures, which transform them directly into metamorphic rocks. So yun na nga. Example dito is yung igneous rocks na hindi nakalabas sa hindi siya nakalabas sa Earth's surface. So ibig sabihin, nandun lang siya sa ilalim, which is malapit sa magma. So, dahil sa compressional force, and high temperatures dun, may chance na kahit hindi pa siya maging sedimentary, magiging metamorphic na siya. Kasi yung metamorphic, nakikreate siya from pressure and heat. So, ganun yun, parang nag-i-skip siya ng Here's the picture of the rock cycle. So, from magma to volcanic eruption. So, crystallization of magma to igneous rocks. Then, weathering and erosion. Transport and deposition. So, ibig sabihin, pagpapalit ng lugar. Sedimentation. So, yun na mahaluan na sila ng sediments. Compaction, cementation. So, after nun, sedimentary na. So, next, burial, high temperatures and pressures. So, nasa ilalim. So, magiging metamorphic. After, then, yung metamorphic is matutunaw, melting, then balik siya sa magma. Then, maulit yung process. Weathering naman, from sedimentary rock, slow uplift to the surface, kukunin ulit ng weathering and erosion, after ng transport and deposition, balik sa sedimentation. So, stay pa rin siya sa sedimentary. Then, metamorphic naman, pwede naman, from metamorphic to weathering and erosion, after ng transport and deposition, magiging sedimentary rock siya. So, it depends na lang kung saan papunta yung kung saan papunta yung batong yun. So, next we have rock deformation. This is the process of changing or transforming rocks due to heat or stress. Parang parang metamorphic ganun. Pero, changing or transforming rocks due to heat and stress. Yung stress dito is pwedeng breaking, kung mahaba siyang bato, bending, ganun. So, next is structural geology. This is the study of laws of motion as they pertain to the deformation of rocks within the earth. So, laws of motion to as they pertain to the deformations of rock within the earth. So, laws of motion in the deformation of rocks within the earth. So, stress. This refers to the pressure applied on a rock that causes deformation on the rock's shape and volume. This can be classified into 3. Ilang ba to? So, next we have confining stress, which is also called as lithostatic stress or uniform stress. Confining stress is the force that is equal in all directions. It does not usually deform a rock but may result in a change in size. Example dito is yung batong yan is palaging nilalagyan ng sabihin natin na mabigat na bagay na, pero na-occupy yung buong surface area niya sa ibabaw, yung face area niya. So, ibig sabihin, uniform yung stress na binibigay nun. Actually, hindi siya nagde-deform ng rock, pero mag-change in size. So, ibig sabihin, ganun pa rin yung ganun pa rin yung shape, pero medyo lalawak, ganun. I don't know tama yung term. Lalawak, ganun. So, next we have differential stress. This is the stress that is not equal in all directions and is caused by tectonic forces. It usually causes a change in shape but not in size. So, ibig sabihin dito is, this is the stress that is not equal in all directions. So, ibig sabihin, pwedeng isang side lang, yung papunta lang right side, yung malakas yung stress, then yung papuntang left is hindi. Or pwedeng walang stress, ganun. It's usually cause a change in shape but not in size. So, change in shape kasi nga, hindi pantay. Magkakaroon ng pagbabago yung bato. Pero not in size kasi ganun pa rin yung size niya. Shape lang yung nagbago. So, example dito is, meron tayong radial na rock. So, hindi naman sa radial, sabihin natin tulis-tulis. So, after dun sa after experiencing differential stress, naging round or naging ball type yung bato. So, ganun pa rin yung size, pero yung shape, iba na. So, ganun yung differential. So, tensional stress, also known as stretching stress. It occurs when a rock is subjected to forces that tend to elongate or pull it apart. It results in a normal fall, lineation of minerals, and thinning of Earth's crust. So, mostly itong tensional stress is nangyayari between divergent plates. So, subjected or tend to elongate or pull it apart. Example, within that pole, merong rock. Pero yung rock na yan is kabit siya between two plates na yun. So, pag hiwalay ng plates na yun, yung rock na yan is pinupull yung dalawang plates na yun. So, ibig sabihin, magkakaroon ng fault yung bato, lineation of minerals, makikita mo yung minerals na nakalinya, and thinning of the Earth's crust. Why thinning of the Earth's crust? Kasi, if that movement involves a plate, tatlo, nasa gitna yung sa plate na yan. Pag hinamblot niya, natural na yung plate na nasa gitna is liliit pero hahaba. So, ibig sabihin, mas lalawak yung Earth's crust pero mas ninipis. So, we have compressional stress, also known as squeezing stress. This is produced by the action of equal and opposite forces, the effect of which is to reduce the length of the material. It results to reverse folds, foliation, and thickening of crust. So, ito yung kabaliktaran ng kanina. So, compressional stress is hindi siya nag-elongate and hindi siya ninipis. Mas kumakapal yung crust and mas umiikli kasi pinupush nila yung bato sa isa't. So, next we have shear stress, also known as tearing stress or wrenching stress. When there is equal and opposite forces not acting along the same line, it results in slippage, translation, and strike slip faults. So, dito sa shear stress, from the word shear, so, gunting. Ano yung usage ng shear? Ng gunting. Di ba para ma-tear o para magupit? Dito is, pag nangyari yun sa bato, magkakaroon tayo ng strike slip fault. Sabihin nito yung faults na ito yung faults mostly transform faults to. Yung strike slip faults. So, yan. Slippage, yun na nga. Basta yung not acting along the same lines. Ibig sabihin, iba. Either pahiwalay. Oh yes, pahiwalay siya lagi. Para magkaroon ng tear yung bato. So ito yung pictures ng stress. Uniform, confining pressure, so equal. So sa tension, opposite. Sa compression, push. Sa shear is slide. So ibig sabihin, ito yung keywords. Uniform, equal. tension, pull, compression, push, shear, slide. So, ganun. So, now, we have uses. Oh, so we have strain. This is the change in the volume and or shape of the rock because of stress. Elastic strain, also known as recoverable strain. This is a strain wherein the material returns to its original shape once the stress that deforms it is removed. So, ito naman yung type of rock na after ma-experience yung stress, bumabalik lang siya sa dati after mawala yung stress na yun. So, next, we have inelastic strain, also known as permanent strain. This occurs when the subjected material does not return to its original shape after it is deformed. It can be categorized into ductile strain, also called a plastic strain. This occurs when a material responds to stress by bending and deforming without breaking. Hence, folding occurs. This situation is achieved when there is a high temperature, high confining stress, and low strain rate. So, inelastic strain, ito yung permanent strain, ibig sabihin, hindi na siya bumabalik. Kahit mawala na yung cause of stress, hindi na siya bumabalik. So, yung tactile strain, ito yung plastic. So, ano yung ng plastic, di ba? Nagbe-bend, it can be bended, siyang ma-bend, pwede siyang ma-fold, or pwede siyang ma-deform without breaking. So, ganun yung ductile strain. So, brittle strain naman. This occurs when a material responds to stress by breaking and fracturing. Hence, there is faulting. This situation is achieved when there is a low temperature, low confining stress, and high strain rate. So, ibig sabihin, sa brittle strain came from the word brittle. So, mabilis ma-break, mabilis ma-fracture. So, magkakaroon ng faulting. Ibig sabihin, magkakaroon ng fault lines yung batong yun. So, rock stress influencers. So, first we have temperature. Rocks became softer, more ductile at higher temperature. Kasi nga, malapit na siyang mag-melt. Rocks at mantle and core temperatures are ductile and will not fracture under the stresses that occur deep within the earth. So, ibig sabihin, kahit anong stress ibigay ng crust sa rocks na yun, if napakainit sa lugar kung nasan yung batong yun, hindi siya magbe-break. Okay? Magbe-bend lang siya, magpo-fold lang siya, pero hindi siya magbe-break. So, next we have confining stress. Since rocks cannot move, they cannot deform. Compression squeezes rock together, causing rocks to fold or fracture. So, ito naman sa confining stress, squeezes rock together. So, pinagsama-sama niya. So, ibig sabihin, magkakaroon ng folds. Or, if matulis yung isang bato, pwede magkaroon ng fracture. Lalo na kung mas matibay siya kaysa dun sa isa. Or, mag-break yung bato. Time and strain rate. If ever the strain rate is low or the temperature is high, rocks that we normally consider brittle can behave in a ductile manner resulting in such folds. So, ibig sabihin, if the strain rate is low, kahit brittle pa yung batong yan, sabihin natin na pinag-aralan natin and we concluded that rock is brittle, pag temperature is high enough, then that brittle rock can behave in a ductile manner. Sabihin, pwede siyang ma-bend. Diba, nakakaano? So, brittle siya. Concluded as brittle, pero pwedeng ma-bend. That is because of the strain rate and the temperature. So, next we have composition. This is important in two ways. So, A, we have mineral composition. Some minerals such as quartz tend to be brittle and are thus more likely to break under stress. Other minerals such as calcite, clay, and mica tend to be ductile and can undergo much plastic deformation. So, mineral composition. Ibig sabihin, ito yung composition ng minerals na magde-decide sa 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 property niya if it is brittle or brittle or ductile. So, ibig sabihin, yung rock na yan, pag kinompose siya ng minerals na ganito, and that minerals are puro brittle minerals, then that rock is also brittle. Then, if puro naman ductile yun nandun sa kanya, then that rock will be ductile. So, next, we have amount of water in rocks. In addition, the presence of water in rocks tends to make it more ductile and less brittle. Yes, bakit? Hindi lang sa temperature nang babase yung ductile and brittle. Ano mangyayari pag nilubog mo isang bagay sa tubig? It will soften. So, lalambot siya, including rocks. Kaya nga yung mga bato na nasa ilog, mostly mapapansin mo, hindi siya matatalim. Why? Kasi nga, after a few years na nasa tubig sila, lumalambot sila. Then, dahil sa water flow, nadadala sila ng tubig. And every time na nadadala sila ng tubig, tumatama sila sa ibang rocks. So, they keep on hitting other rocks until to the point na wala na silang sharp edge. Puro na lang soft. Then, mag-roll na lang sila sa bato. Sa ibang bato. Mag-roll na lang. So, after rolling, then, nag-settle down yung bato. After mag-settle down ng batong yan, mapapansin mo, yung batong yan is almost round, if not round. Wala siyang sharp edge. Napakakinis niya. Kasi nga lumambot na siya. So, nag-iba na yung shape niya. Dahil sa lambot, dahil sa ductile. So, next, folds. So, folding. This is the bending of rocks deep in the crust promoted by high pressures and temperatures. It is caused by various geologic forces from small changes in pressure on the crust up to the clashing of tectonic plates. So, folding is the bending of rocks. Ibig sabihin, ito yung pag-bend ng rocks deep in the crust. So, nasa ilalim, hindi sa ibabaw ng crust, okay? Promoted by high pressures and temperatures. So, yung high pressures na to is mostly compression. Ibig sabihin, yung pressure na pag-compress. So, next we have fold. This occurs when one or a stack of originally flat and planar surfaces such as sedimentary strata are bent or curved as a result of permanent deformation. So, ibig sabihin, yung fold na to is yung product of the permanent deformation. So, ano yung deformation na yun? Ito yung folding. So, changes in pressure and temperature. Kasi nga, di ba, pag mataas yung pressure and temperature, lumalambot yung rocks. So, pag nag-bend sila, or naging curve, then, saktong inelastic yung rocks na yun. So, ibig sabihin, hindi na babalik. After nun, magiging permanent yung deformation niya. Yun ang tawag na sa kanya is fold. Fold na yung tawag sa nangyaring yun. Yung product na yun. So, next we have Parts of folds. So we have parts of folds. So fold axis or hinge line. This is the axis of a fold where the curvature is greatest. So dito yung pinakamalaki yung curve. So next we have limb. This refers to one side of the fold. So ito yung sides ng fold. So next, axial plane. This is where the hinge line lies, and it separates the rocks on the one side of a fold from the rocks on the other side that dip in the opposite directions. It contains the fold axis of each folded layer. So ibig sabihin, axial plane, this is where the hinge line lies. So ito yung hinge line. So yung parang separation. Ito yung nagsiseparate ng rocks sa limbs. So, nose, this is the tip of a fold. Ito yung pinaka-dulo. So, deep, this is the steepness of the limbs and it reflects the intensity of folding. So, malalaman mo kung gaano ka-intense yung folding depende dun sa deep. Kung gaano ka-steep yung deep. So, strike. This is the compass direction of the fold or the rocks layer or the rock layers in it. So, strike, ito yung compass direction. So, north, south, east, west, compass direction. So, plunge, this is the angle between the horizontal and the hinge line. So, yung plunge, this between the horizontal line and hinge line. So, yung mini-measure dito is yung angle. So, pag sinabing angle, then it is plunge. So, ito yung picture. So, this is the axial planes. Ito. Then, the hinge lines, the fold axis. We have the limb. Then, the syncline, anticline, and the axis. So, what are anticline and syncline? So, dito siya sa types of folds. Monocline. This is a fold in layered rocks that creates a slight bend and forms a large step-like fold. So, monocline, sabihin, slight bend lang. Parang ladder lang, ganun. So, anticline, this is an upturned fold and it forms a true. The hinge is at the top, the limbs downward, and the younger strata atop the older strata. It usually forms mountains, hills, and ridges. So, pag nakita nyo yung mountain range, hills, and ridges, or simply mountains, pwede siyang if not dahil sa fault line, then it is an anticline fold. So, syncline, this is downturned fold and it forms throws. The hinge is at the bottom, the limbs upward, and the younger strata atop older strata. It usually forms valleys. Valleys kasi nga, tawag ito, payu siya. So, mostly magkasama si anticline and syncline, especially pag valleys, valleys and ridges yung nangyayari. So, overturned. This fold is formed when one limb is steeper than the other. So, ibig sabihin, hindi pantay yung limbs. So, synform. This is a fold wherein the hinge is at the bottom, limbs upward, and the age of the strata is unknown. So, para siyang syncline. Pero, hindi alam kung ano yung age ng strata. Kasi sa syncline, yung younger strata is above older strata. So, dito sa synform, hindi nila alam kung anong age ng strata na yun. So, next, antiform. This is a fold wherein the hinge is at the top, the limbs downward, and the age of the strata is unknown. Same as anticline, pero same as synform, hindi rin alam yung age ng strata niya. So, synformal anticline. This is a fault wherein the hinge is at the bottom, the limbs upward, and the older strata above the younger strata. So, ibig sabihin, ano to, parang pinaghalong anticline at syncline. O synform at anticline. So, the limbs is upward, hinge is at the bottom sa synform, then older strata above younger strata sa anticline. Then next, we have antiformal syncline. This is a fold wherein the hinge is at the top, the limbs downward, and the older strata atop younger strata. So, antiformal syncline is antiform and syncline naman. So, the same lang din, kabaliktaran lang siya ng synformal, ganun. So, next, these are pictures and types of folds. So, we have monocline, parang step lang. We have the synform and the antiform. So, hindi natin alam yung age. So, we have the syncline and anticline. Diba? The same lang. Pero may age yung strata nila. Then, synformal anticline, kabaliktaran. Yung younger is nasa ibabaw. At antiformal syncline, yung younger is nasa ibabaw. So, synformal antiform, antiformal syncline, anticline, syncline, anticline, and synformal anticline. Kumbaga, ito yung mangyayari pag pinagsama-sama yung synform, yung syncline at anticline. So, we have faults. So, okay, we have faults. This is a planar fracture discontinuity in a volume of rock across which there has been a significant displacement as a result of rock mass movement. It is caused by a brittle deformation wherein tectonic forces fracture the rock mass. Hence, this deformation is a source of earthquakes and also mineralization. So, yung fault, actually hindi na siya unfamiliar sa atin. So, fault is a planar fracture. Ibig sabihin, fracture sa planes. Planes is also equals to plates. Okay? So, ito yung parang sugat-sugat ng plates na caused by rock mass movement. So, ibig sabihin, malakihang movement ng malaking bato. So, bakit nagkakaroon ng fault? Firstly, brittle yung rock mass na yun. Kasi if ductile lang, folds lang yung mangyayari, mostly monocline. Pero since brittle siya, so pag brittle siya, ibig sabihin magbe-break. So yan yung fault. After ng breaking, yung makikita mo is yung fault na yan. So, let's move on. Parts of fault. So we have first our fault plane. This represents the fractured surface of a fault, where you can find the focus and the movement. So, ito yung fractured surface ng fault. Dito, parang dito mo makikita yung focus and movement. Ito yung sugat. So, fault trace or fault line. This is a place where the fault can be seen or mapped on the surface. It is an edge of the fault that shows how much movement has taken place. So, ito yung mostly nakikita natin sa maps. So, yung pinapakita sa TV. Example is, ito yung fault line na makikita sa gantong lugar. Or yung fault line na magkakos ng the big one. So, fault line yun. Kasi nga nakikita sa map. So, fault zone. This is a zone of complex deformation associated with the fault plane. Complex deformation, ibig sabihin, parang yung deformation dito is hindi katulad na ibang deformation sa fault plane na yan. Iba siya. So, fault scarp. This is the term used to refer to when the fault plane is exposed above the ground. So, ibig sabihin, yung fault, pag nagkaroon ng movement yung fault plane, and yung fault plane na is napunta, ay na-exposed above the ground, yung part na yun is tinatawag na fault scarp. So, fault gauge. This is the broken material within a fault. Ito yung mga broken materials na makikita sa fault. Either rocks, trees, or anything basta broken materials. So, next is hanging wall. This is the block of rock resting on the fault plane. So, yung hanging wall is, ito yung block of rock. Excuse me. Ito yung nagre-rest. Ibig sabihin, if diagonally yung fault line, which is common, diagonally, yung nagre-rest sa diagonal part, that is the hanging wall. So, mostly siya yung nasa ilalim. Or pwede rin nasa itaas. Depende kung saan yung movement. Basta, yung part na, di ba, yung diagonals, we have diagonal na yung isa is parang reverse triangle, yung isa naman is right triangle. Yung nagre-rest sa right triangle, yun yung hanging wall. So, fault wall, this is the block below the fault plane. Ito naman yung kabila ng hanging wall. Ibig sabihin, below the fault plane. Sa ilalim ng fault plane, that is the fault wall. So, mostly nasa kabila siya ng hanging wall. So, next, types of faults. Faults based on reactivities. We have active faults. These are faults that have generated earthquakes within the last 10,000 years. So, last 10,000 years, ibig sabihin, kahit ilang beses silang nag-cause ng earthquakes, basta within the last 10,000 years, they are considered as active. So, inactive naman, if these faults do not show signs of ever having generated an earthquake in the last 10,000 years. So, ibig sabihin, pag hindi na sila gumalaw within 10,000 years, inactive faults na sila. So, faults based on their movement. So, we have deep sleep fault. These are faults caused by the movement of blocks, mainly in the vertical direction. So, deep sleep, vertical direction, pataas. So, normal fault. This is a fault wherein the hanging wall moves downward with respect to the foot wall. It uses tensional force and causes the stretching of rocks. It is also called gravity fault. So, ibig sabihin, yung normal fault, ito yung pababang movement ng hanging wall. So, it uses tensional force kasi nga, pababa siya. Ibig sabihin, yung rocks na nandun is mabibend and mapupul habang bumababa yung hanging wall. So, tensional force. Then next, we have the graben fault. This fault is produced when tensional stresses result in the subsidence of a block of rock. Tensional stresses result in the subsidence of block of rock. So, ibig sabihin, nag-subside, gradual sudden sinking or gradual downward movement of the ground surfaces. Pero dito naman is block of rock. So, nag-sink yung block of rock na yun. So, reverse fault. This fault is formed when rocks are compressed. The hanging wall moves up with respect to the foot wall, causing the length of the rock body to shorten. So, kanina, tensional. Ito naman is compressional. Kasi nga, pinocompress. Habang pangit yung hanging wall, lumiliit or umiiksi yung length ng rock na yun. So, thrust fault. This is a type of reverse fault that has a depth of 45 degrees or less. So, pag 45 degrees or less yung deep ng fault, then it is considered as thrust fault. Forced fault naman, this is a fault that is developed when two reverse faults cause a block of rock to be pushed up. Ibig sabihin, reverse fault. So, dalawang reverse fault. Umakyat yung dalawang yun. Then, meron silang na-push up na block of rock. Pwedeng nasa gitna. Hindi yung nasa gitnang footwall. Either nasa ibabaw nun. Samples nasa ilalim yung yung fault na yun. So, sabihin, pag na-push nila, push up papunta sa taas. So, yun yung first fault. So, next we have the strike slip fault, also known as the transcurrent fault. And its movement is chiefly in horizontal direction. So, pahiga lang. Hindi siya katulad kaninang vertical, pataas or pababa. Ito is left and right. So, right lateral strike slip fault. This strike slip fault is also called as dextral fault, and the movement is to the right. So, yung movement ng fault or ng rock is punta sa right. Then we have the left lateral strike slip fault. This strike slip fault is also called as sinistral fault, and the movement is to the left. Yung kanina sa punta sa right, at naman sa punta sa left. So, oblique slip fault naman. This type of fault exhibits both deep slip and strike slip movements. So, ibig sabihin, pinaghalong deep slip and strike slip, yung oblique slip. So, joints, these are natural cracks caused by tensional stress resulting in brittle deformation. It is a fracture where there is no displacement along the rocks. So, fracture lang siya caused by tensional stress resulting in brittle deformations. Ibig sabihin, made-deform, maka-fracture, pero walang displacement ng bato. Hanggang dyan lang siya. Okay? We have unconformity. This is any significant break in time within stratigraphic column. It represents a passage of time. Unconformities are gaps in the rock record representing a long period during which deposition ceased, erosion removed previously formed rocks, and then deposition resumed, and a period of non-deposition. We have disconformity. This is an unconformity in which an upper sedimentary sequence overlies an erosional surface developed on an undeformed, still horizontal lower sedimentary sequence. So, dito ang disconformity is pag yung an upper sedimentary sequence is nag-overlay sa isang erosional surface nag-overlay ng erosional surface sa isang undeformed na sedimentary sequence. So, next, nonconformity. This is an unconformity in which the upper sedimentary beds overlie metamorphic or igneous rocks. It is between distinctly three different rocks. So, ibig sabihin, overlay metamorphic or igneous rocks. So, yung sedimentary beds, tinabunan niya yung metamorphic and igneous rocks or igneous rocks. So, ibig sabihin, parang tinakpan niya. Hindi niya pinayagang makapunta sa ibabaw yung metamorphic or igneous rocks. So, ang nonconformity. This is unconformity where the rock layers show different dips and strikes from those of the rocks below. In angular unconformity, the two sequences have bedding planes that are not parallel. So, ibig sabihin, dito sa conformity na to, yung dalawang sequence, hindi parallel yung beds nila. Okay? So, hindi din naghalo. Hindi lang pantay. Ganun. So, we have this picture. So, sa disconformity, so, tinabunan niya. Ganun. Ito is, sabihin natin na horizontal. Yung kanya is vertical. Yung, yan. So, dito naman sa non-conformity, vertical, tapos yung, is, itong yellow na to, wait lang. So, itong yellow na to is sedimentary. Ito. And this is the igneous. So, dito naman sa angular unconformity, angles ng, at ito yung angular na ito yung tilted eroded layers. And this is the sedimentary, or the sediments. Yan, sediments yan. So, next. Thank you for watching and listening. This is Talay Katangkay, your instructor 1 for geology. So, thank you. Bye-bye.